Am I audible? Okay, just replay. I think I'm audible. Um, okay. So first of all, this class is today we are going to see about the page replacement algorithm. Last class in slide itself we have seen something about page replacement. But in deep, I just want to add something. Okay, so here is the presentation. I think I am audible, right? Okay. So there are what is called paging and what is a page replacement and what are the algorithms and I mean the including the conclusion. We have this flow and what is the paging. First of all, for every OS derives the virtual memory. I mean from the so it has to handle it cannot handle for throughout the request it cannot handle it, so it has to convert as a page, so that is called the paging. So the OS derives the virtual memory and the main memory into units called pages, so the small units called pages, and each used page can be either in secondary memory or page frames in the main memory. So for every page can be either in a secondary memory or can be the page frame in the main memory. So the third one is a frame does not have to comprise a single physically contiguous region in secondary storage. So that means so the pages I mean the for frames it should not I mean it doesn't have any comprise means after that it should not can I mean it should not minimize it for a single physically contiguous region in a secondary storage. So normally it may have the secondary storage, the pages can be divided and it is stored in a secondary storage or in a page frame in a main memory. Okay, and after that the page does not have any comprise a single physically contiguous region in a secondary storage. So it doesn't I mean it cannot limited in a region of the secondary storage. Then what is a page replacement? So this is what actually we are going to see about what is a page replacement. So when the so for example whenever the page is working on something, we have to replace it for our next process or next task. So for that we need to replace the existing page. So for that alone, when the memory located in the second memory is needed, it can be retrieved back to the main memory. So whenever the secondary memory is occupied, we have to retrieve I mean we have to allocate it to the main memory or we have to taken away from the main memory. So for that the process of storing data from the main memory to the second memory, that's called the swapping out. So swapping out means it's just an interchanging process of the storing data from the main memory to the secondary memory, then retrieving the data back to the main memory, that's called swapping in. So first of all you just there is a two difference. One is the swapping out means process of storing the data from the main memory to the secondary memory. That means we are taking away from the main memory to the and giving to the secondary memory. Then swapping in means from the data back to the main memory. That means from the secondary memory to the main memory. That's called a swap. So I think both concept is you have understand. Now the what is called the frames, and for example here is a page table. In the page table you could see that there are numbers I mean there are alphabets are stored in there, and maybe the valid bits are there or invalid bits, maybe every bits are stored in a page table. So for a page table each and every column is the frames. Okay, so the page may be the based on the memory size, the page may be differ. And here actually we have a physical memory. In that physical memory, we can have from the secondary memory, we can make it a swap out or swap in. I mean, the page can be getting inside or page can be getting outside from the physical memory or the main memory. Okay, that's a small diagram for this. And what are the page replacement algorithms? So, I mean, earlier we have seen about the some of the algorithm like first in first out algorithm and kind of swapping and these things, but we will see in detail. So the details in which pages need to be swapped out and which are the ones needed to be swapped in. So how to deal with that physical memory? I mean, the which with the main memory and secondary memory, how we are dealing with the page replacement algorithm. So this is about it, and the efficiency lies in least time, and that is wasted for the page to be paged in. So the efficiency also should be placed in account. Then it can be taking as a, I mean, it should be work within a limited time, within least time, that can be modified accordingly. So this is about the page replacement. So we'll see the algorithm one by one. Now the next slide is, so types, there are two types. One is the local page replacement algorithm and a global page replacement strategy. I mean, the locally means within the constraints, within the local constraints, and global page replacement means maybe we have to set the large number of scope on it. So why we need a page replacement algorithm? So earlier I have told you. So the pages can be a part of the task. So that can be replaced because we have to um, make a new pages into the our I mean the existing work. So that the main goal of the page replacement algorithm is to provide the lowest page fault rate. So lowest page fault rate means if we couldn't access the page, then there is a page fault problem. So page fault rate may be if it the page fault rate is increasing, then actually we couldn't access the pages. Okay, so the algorithm means for every algorithm in computer science, that is a method. Algorithm is a method, and through the method, we have to make the efficiency. Maybe the time complexity will be high. I mean, within the timeline, within the very limited time, we have to make it, and also the space complexity will be. I mean, the it should occupy the less space. I mean, the whatever the process we are doing it. I mean, we have to increase the space complexity. We have to decrease the time complexity. This is the two things for following for every algorithm, for every computer science algorithm. These two things actually we have to follow. In concern with the page replacement algorithm, the main goal of the page replacement algorithm is to provide the lowest page fault rate. I mean, the page fault is actually occur if we couldn't access the page, then the page fault can be occur. So we have to decrease the page fault rate. So here there is a start, and after the start there is a, I will maximize the screen just a minute. So here is we have a start, and after that there is a request for page request, and if the page found, right, if the page found, then it goes to hit, right. I mean if the page found, then we can execute it, that called hit. And if the page is not found, then the page fault will be there. Then after that we have to fetch the page. I mean, if the page fault is occur, then we have to fetch the page. Then after that we have to stop this is about the single page. The page request. Okay, so if we want to access the page, I mean, the from the secondary memory or main memory, it has to send the page request. If the page is found on based on the request, then we can go for hit and then we can stop it. If it is not found, then we have to report for the page fault, and then we have to fetch the page based on the. I mean, again we have to go on fetch because we need to give some extra effort on the fetching the page. Then we can go for the stop. Okay, that is the process about. And for this, yeah, this is small pie. I mean the pie chart. So the number of page faults versus number of frames. So if the number of frames is increasing, so let's say here the number of frames is increasing, then the number of page faults should be decreased. If the number of, I mean the page faults is increasing, then the number of frames could be decreased. So that is the equal. I mean the this kind of ratio we have to follow it. So algorithm, there are a lot of algorithms. One is the first in first out, an optical replacement, and which is not recently used. I mean earlier we have seen in the previous slide. First of all, we have seen the first in first out. Then we have seen the not recently used and not frequently used, and then the optical replacement and chances and clock and not frequently used and least recently used and random replacement and working set replacement. So these many algorithms are following for page replacement methods. So one by one we will see it. So first in first out as a queue. So as a queue structure, whichever goes to the first page, so that can be replaced by the page. I mean the page replacement algorithm, and the newest will be in a tile. So the pages in the main memory are kept in a list. Then newest page in the is the head and the oldest in tile, and it does not take advantage of the page access patterns or frequency. So whichever comes first, it goes, and then after that, whichever enter the last, and it can process of the last. I mean, it can replace in the only at the last time or last place. So this is about the page. I mean the FIFO. So the new page has inserted to the head. That's called A, and title. I mean the tile. That's called Z. So whenever the new process comes, it has to come as in a head portion. Then the child can be replaced. I mean it can be vanished, and then the new pages can be added in the head. Then for this example is for this you can see there, these are the pages. So pages having three values. For every three values we are just adding the here we are just, I mean these are the values actually we are adding here. So here we just adding it 7, after that 0. Actually the 7 is there, and here actually we are adding 0, and here actually we are adding 1. Now actually the page is replacing, instead of 7 the page is replacing as 2. Now the hit will be there. I mean whenever we are adding a new page frames, then there is a hit because we have an extra one, because we having 701. There is no problem on it. Now we just adding one more string on it. So then the oldest only will be replaced, and the newest one will be I mean the occupied in the oldest part. So now the 201 will be in the as per the newest page. So here actually what happened, here actually the hit is done. Then afterwards the newest will be added once again, which is the 0, I mean the 2 3 1. So there we can access 0 3 can be added. So likewise, so whenever the newest value is added, so there is a hit, and so whenever the routine values, that called FIFO, whenever the routine values are adding, so we just keep on adding it. Then we can just differentiate between the hit and page fault. There is no page fault here. I mean we just keep on adding whenever the new strings are coming. We just keep on adding in the form of the FIFO. So that is the method, okay, for the overall reference strings. So finally, you can see that there are if the numbers are repeating, we cannot have the hit. If the numbers are newly comes, then we can have the hit. And yeah, so like this we can have it. So 224444, and there is no hit. I mean, the here we can have the number of hits. So 1 2 3 hits, because hit means we don't have any problem. There is no page fault. We can directly have the hit. So next we can go for the next one, that's called optical replacement. So optical replacement is the name itself. Optical means how we can make the efficient, how we can make the I mean the look forward. Okay, if we are look forward some strategy, then we can go for that kind of optical replacement. Now, when your memory is full, okay, that means the page is occupied, then that's evict a page that will be unreferencing for the longest time. I mean, when memory is full, then we cannot refer any kind of patterns or any kind of pages for a long time. Then the OS keeps tracks of all pages referred by the program. Then the operating system keeps tracks of all pages referenced by the program. This is actually a problem statement. Why the optical replacement is can be introduced. Then, if only the program memory reference pattern is relatively consistent, so then the program's memory reference can be only by using the program memory reference only we can allow for any kind of page replacement. Then we can follow the optical replacement. That means if the memory is already full and the OS is also busy and we cannot refer any kind of page reference, so then the thing is the program's memory can be referenced as a pattern in relatively consistent. So here there is a optical I mean the optical replacement example. So you can see that whenever the repeated values are there, then we can have the hit, and whenever the new values comes, we just adding it. Okay, so here you can see so whenever, see for example 2 3 is already there, and 3 2 already there, and 2 0 1 already there, then we can have the hit value, and whenever the new values comes we can add it. Okay, so this kind of optical, I mean here what is the difference between the FIFO and the optical means, the FIFO logics actually we are following it, so we just adding the new number to here, but optical means we can just replacing whenever the new number is coming. I mean whenever the new reference string is coming, we're just replacing with the hit. Okay, so this is the example of the optical communication, I mean optical algorithm. Okay, optimal algorithm. So these are the two difference. Then the third one is not recently used or not frequent. I mean it is only within the number of within the particular time. I mean whichever the which we are not using, which earlier, I mean recently we are not using it. So in that case only, in the favor of keeping pages in memory that have been recently used, okay, we have the pages in a memory that have been recently used. So every pages in a memory we are just keeping it which is the recently used. Then the OS derives the page into 4 classes based on the usage during the last clock trick. That means we just keeping the pages in the recently used memory. Then afterwards the OS derives the page into 4 classes based on the usage of the during the last clock trick. So what are the how many they are classified and how they are classified which is not recently used. So one is the 3 referenced or modified. So three referenced means the finally, I mean the modified by modified as well as the three times is referred, and two times referred and not modified. Two times it is getting referred and but it is not modified, and not at all referred and but modified, and zero times is not referred and but not modified. So these are the things for recently used. I mean not recently used. Just a minute. Okay. I think is it visible for you? Let me see the. Okay. Am I audible? Okay. Okay. So I will proceed now. Still we have time. So these are the I mean not recently used. So now we can just come to the our actual class, which is not recently used. Now for the method, what actually we are following the method is pick a random page from the lowest category for removal. So we just pick the random page from the lowest category for removal. Lowest category means which should have the very limited number. I mean which limited strings. I mean very limited strings. Whichever the page is there, we just pick the random page, and then if it is not referred and not modified, for example it is not referred, how it is telling, I mean how it is not referred not modified means, here is the example. Here you can see that the same kind of example. So we just pick the random. So first initially we just go and pick it this page, and here there is yeah, there is a zero is there, so there is a hit, but we didn't referred as a hit. So how we are actually, how the reference means whether it is referred as hit or not. And then there is a one more term that's called just a minute, modified. So if it is hit, then only we just do the modification. Okay. So the difference between both I mean the both earlier algorithms and this algorithm is that there we just take care of, I mean the gradually we just go for one by one, that's called a FIFO. And next one is I mean we just, there's the same patterns we'll be following for FIFO, but we do the we have to apply the smart kind of modification, that's called the name is just a minute, yeah, optimal. Then there we don't have access of actually randomness, but here it's already processed by using the optimal method, and there we just take a reference of a one page, and from that page whether it can be hit or whether it can be modified, whether it can be referred or hit. So then we it has to check it, and finally we can proceed the same, which is the same as for your optimal. So I think you are getting it. So if possible I can give some more example with limited strings, because here we have nearly 20 strings. So we can take away, I mean take only 2 to 3 strings, and then we can process the repeated strings, and then we can easily understand the last three concepts of this. Okay. So the next one is the actually second chance. So it is the one more algorithm. Then algorithm is a modified versions of the FIFO. That's a modified versions of the FIFO. I mean the first in first out. And instead of swapping out the last page, the referenced bit is checked. So instead of swapping out the last page, that means we are just, whenever the FIFO, we just swapping out, I mean we just replacing that using the new string, we just replacing it. Then instead of it, the reference bit is checked. The reference bit is checked means it can be goes for hit and gives every page as the second chance. So every time we have to do it for the twice. So that is called the second chance. Now the same example. Okay, so the new pages is inserted in a head, and if reference bit is set to be page is moved to the head for the next page is taken. So here actually what we are doing it, the difference between these two is the new pages is insert to head. The second chance is whenever the new pages is added in a tile, then that can be added into the head once again, then that can be checked. So this is the this is about the second chance. Okay. So next class we will see that actually the even the strings and values, how they are going for it and how it is referred. Now we have only the diagram. Now the CLAC, again the CLAC, one more algorithm, that's modified versions of FIFO, and they're said to be frame candidates for replacement is considered as the circular buffer. So that means here you can see that the circular queue of pages, queue of pages. The first one is, I mean the reference bits. We have the 0 and 1 and whatever we having it, and first we, I mean whichever the modified version, whichever the we have the first one, we just having the next victim, and that's called the, I mean the pages can be replaced the same as your last previous example, right? So the same as second chance, how it is replacing the same, it is process for the CLAC, I mean the CLAC cycle. Okay, so that, I mean this is one of the example is circular queue for the pages, and this is second example. So any new modification comes as the reference bits, then it can be taking as the reference bits, then it is modifying from the last, I mean the whichever the modified bit, then it is I mean replaced by the earlier bits. Okay, so that is called the circular queue or circular bit. So last recently used, that's one more thing. I mean the clock and actually the clock as well as the second chance is not actually in our actual syllabus in our, as per your book, but these are the normal frequently, I mean the algorithms are there as per the thing. Next one is least recently used. For least recently used, is for that we have to do many things, because whichever is the very least used string we have to find out, and then only we can do the least recently used example. I mean the heat, whether it is going for heat, the same example only, but we have to compute it whichever the least recently used string. Okay, so this is one more example of algorithm. And not frequently used, the same, but it's very rarely used. So least free, I mean the this thing is least recently used, I mean recently whichever used as a least, so that is the LRU, that's called least recently used. Then the one more thing is not frequently used. So how the not frequently used means, not at all used, it's very rarely used. Okay, so that thing can be identified, and so these are the pages only. Okay, so that thing can be identified, and then that can be denoted as the least frequently, I mean the not frequently used. Okay, so these are the concepts only, you just go through it. I will give the some more example, and I have given, I will give the real example. Yeah, so these are the, and then one more is the random. So okay, up to that we will finish it. Okay, we will see in the next class. So now we will check with whether we got it screen sharing or not. I will check it and then I will let you know. Now we will end our broadcast. See you.